Good afternoon, guys. 4 p.m. Let's start our class. So today, April 13, and we're gonna work with chapters 9 and 10. Okay. So we start with chapter 9, and let's recall formulas first. So future value, present value 1 plus I exponent n, present value, future value 1 plus I exponent negative n. So far, those two formulas. Just to recall that formula for future value we use when we move money together with time. Formula for present value we use when we move money opposite direction together. Okay, those formulas and I is J over M, N is Tm, also M assumes values 1, 2, 4, 12, 26, 52, 365. And also we use notification JM, right, for our convenience. Okay, any questions? Okay, so let's continue. Let's practice some exercises. So loan for 5,000 with interest 7.75 compounded semi-annually is repaid after 5 years, 10 months. What is the amount of interest paid? So loan is present value. We have J2 7.75%. Okay, and we have T 5 years, 10 months. And interest. Interest is a difference between amount you pay and amount you borrow. Here we're talking about loan, right? So let's find out how much we pay. So first, I would say we deal with time. So 5 plus 10 over 12. Let's see what is it. So I have 5.83 period. Now we calculate n right away. That's Tm. So that will be 5.83 period times 2. So times 2. 11.6 period. So I memorize it. Now let's do I separately. 75.2 0.03875, and future value finally it is 5,000 1.03875 exponent 11.6 in period. So let's calculate. Have $7,791.10. Now we can find interest amount, and interest amount it is 7,791.10 minus original loan of $5,000. It's 2,791.10. Any questions, guys? Okay. So let's continue. An investment of 2,500 earns 4.5 compound monthly for 3 years. At that time, interest rate changes to 5. How much accumulated value 1.5 years after the change? So let's make it the timeline. We have now investment. It is present value again. So 3 years. And 1.5, it will be 4.5 years, right? So we have, let me highlight it here, this interval. I have J12, 4.5%, and that interval I have J4 is 5%. Okay, so now we can what, calculate whatever we can to the point of transaction, and it is future value. So future value of 2,500. So what is 4.5 monthly? That's 1,00375. Now 3 monthly 36. Let's calculate. So 286062. Let me double check. Yeah. So this amount is right here. Now we take it as a present value, and we keep going for the next year and a half. So 286062. The difference is what? Is interest rate. So year and a half times 4 gives me 6. $3,081.98. And this amount is already here. Any questions, people? Okay, keep going. Terry started an RRSP on March 1, 2016 with a deposit of 2,000, and she added 1,800 December 1, 2018 and 1,700 to September 1, 2020. What is the accumulated value of her account on December 1, 2027 if interest 7.5 per quarter? So interest rate is steady, no change. So what we do, we add additional deposits to our account. So 2,000 right sits here. So I have December 1, 2018, and we add 1,800 here. I have September 1, 2020, and I add 1,700 here, and I have December 1, 2027. So let's work with time and so let's do our basically preparation. So what is it? March 1 to December 1. We have 2 years, and what is it? April, May, June, July, August, September, October, November, December, 9 months. So 2 years, 9 months, right? Or 275 years. Is that right, guys? let's do here December. So if I shoot till December, I will have 2 years, but then step back, what is it, October, November, 3 months. It would be 1 year, 9 months, or 175 years. Okay, let's see what's next. So if I go from December to December, I have 7 years and 3 months. So 7, 25 years. So far, any questions, people? Okay, so let's find n for each. 275. 1 year, 9 months. 175 years. It's 1 year, 9 months. Understood? Well, if I go from December 1, 2 years, I will have December 1, 2020, and plus 9 months, it will be already year 2021. But you go only till September 1, 2020. So, what are you talking about? You're talking about first from March 1 to December 1. It is 2 years, 9 months. But from December 1 to September 1, that's 1 year. Okay. December 1, 2018. December 1, 2019. December 1, 2020. Yes? 2 years? 2 years, right? Yes or yes? September 1, 2020. So it's right there. Understood? Very good. So let's calculate n for each interval. So 275 times 4, n is 11. 175 times 4, n is 7. And 725 times 4, n is 29. So now we're ready to what? Step-by-step calculation. So future value 1, 20,000. 1 point, by the way, what is that? 0.1875. Exponent 11. So 2453 43. Question: do we have deposit here? Answer: yes, we do. So what happened? Let me see if I have the next page. Yes, I do. So we add 1800, right? And the result is 425343. So far, any questions, guys? Okay, so let me flip a page. Now we're here at December 1. So future value 2, 4253. 43 is already present value. So 1.01875 exponent 7, I believe. Let me double check. Yes, 7. Okay, so exponent 7 times 4253, 43, 48, 4409. Do we have deposit here? Yes, we do, 1700. So add them up. And result is 654410. Oh, actually 09. Why 10? 09. Now finally, future value 3. That's that amount. And exponent was 29. So 11,215. Sorry, 28. So that's the final answer actually. What accumulated value? Yes. So we found accumulated value. Any questions? Okay, so let's continue. One sec. Okay, one sec. Okay, question number next. A variable rate demand loan showed an initial balance of 12,000. Payments of 5,000 after 18 months, 4,000 after 30 months, and final payment after 5 years. Interest was 11% compounded semi-annually for the first 2 years and 12% compounded monthly for the remaining time. What was the size of final payment? So let's make a picture. So now 12,000, 18 months, 5,000, 30 months, 4,000, 5 years, I put 60 months. Well, that's payment. Now let's work with interest rates. Oops. Interest rates. So first 2 years, so 24 months. This interval we have J2 11%, J2 11%. Remaining time is this, and we have J12 12%. So any questions, guys? Okay, so we have to stop 1, 2 here, 1, 2, 3, 4 times. Right? So let's do it. Let's do it. So first stop, future value 12,000. And here, guys, we have to understand what process is going, right? So here we pay loan. It means we're gonna deduct those amounts what we put. In the previous question, we accumulated money, so we added those two amounts, right? So you have to clearly understand what are you doing. Okay, so let's see. 12,000 and 11 semi-annual. That's 1.055 for 18 months. So 18 over 6, 3. Right. Plus semi-annual or quarterly? Semi-annual. Plus, no, y plus, no pluses, equals. Equals, so 1.055 exponent 3 times 12,000. 14,090, 90. Okay. So next interval, what is it, 6 months? Yeah, did we have any deposits? Yes, so minus 5,000. So minus 5,000, it is 90, 90, 90. So second interval, let me use what is called. So future value, 90, 90.90. It's still 11%. So that's it. Times 90, 95, 90, 90. Do we have any deposits here? No, we didn't. Right? So next is interval with different interest rate, and that is 12% monthly. So 6 months, so it's like that, times 95, 90, 90. $10,180.93. Did we have any deposits here? Yes, we did. Okay. What is it? 6,180.93. So far, guys, are you with me? Any questions? Any questions, people? Let me know when. Oh yeah, right. We can continue right here. We can continue right here. And finally, future value. 6,180. It should be 80. 93. Interest rate is that. Now I have 30 months, right? So let's calculate. That is 8,330.96. That is the amount of final payment. That is the amount of final payment. Any questions? Okay, let's continue. Let's continue. What sum of money will grow to 2,000 in 7 years, 9 months compounded monthly? So here we have what future value is 2,000 times 7 years. We have J12, 9%. Now we need to find present value. That's 2,000, 1.0075, and 7 times 12 is 84, Negative because it is present value formula, right? Times 2000. So 1067, 69, that's the amount we were looking for. Any questions? Okay, in negotiating a contract, okay, let me know. Minus 84, yes. Yeah. Why 8 years? 7 times 12 is 84. Is 7 years. Why 8? That's this. That's this. Okay? Let me know when you're ready. Okay, so in negotiating a contract for your business, you have to decide between receiving 50,000 now or 20,000 now and 35 3 years from now. In terms of today dollar, which choice is better and by how much? Money is worth 425 compounded annually. So what I have option 1, 50,000 now. Option 2, I have 20,000 now and 35,000 3 years. So is that part clear? Does everyone understand? Okay, so in order to compare them, we need money at one point of time. They say today's dollar, so focal date is now, and 50,000 and 20,000 is already there, so I have to take 35,000 to the focal date. Therefore 20,000 plus 35,000, 425 compounded annually. Yeah, actually it's like that. 3 years gives me minus 3. So 20,000 plus, okay, gives me $30,891.56. So together, $50,891.56. So which option is better? People, option 1 or option 2? Option 2, yes. And they say by how much, and that is by how much? $891.56. That's by how much it's better. Okay, so can we continue? Let me know, guys. Okay, let me see something here. Okay, so here it is. Scheduled payment of 6, 8, and 1200 due in 1, 3, and 6 years respectively. What is the equivalent single replacement payment 2.5 years from now if interest is 7.5 compounded monthly? So let's make a timeline now. 1 year, 600, 3 years, 800, and 6 years, that is 1200. Instead of that, we have 2.5 years unknown payment X. Right? Do we need focal date here, people? Yes or no? Yes. And where is it? Yes. Very good. Focal date is here. So my logic is following. Since I have one payment in second agreement, I can create equation right away. So X is 600. What is it? 7.5 monthly. Let me calculate. That is 1.00625. Okay, give me 1 second. I memorize it. And then 1.5 years times 12. That is 18. Okay, so I move that way. So future value formula, right? Plus 800, 1.00625. And I have half a year, so minus 6 plus 1200, 1.00625. So 6 minus 2.5 years times 12, negative 42. Because both going opposite way to time, right? That's why we use present value formula. Make sense, people? 671, 21 plus 770, 65 plus, oops, times 1200, 923, 71. So now I add them up. $2,365.57. So please confirm my number. So guys, have you finished your calculations? Okay, so question. Was it good decision to pay in a point of 2.5 years? Yes or no? Yes, you have three options to answer. Yes, no, I don't know. So which one you choose? Yes, it was a good decision, right? Because if we pay as we planned, altogether it would be 2,600. By paying faster, we avoided interest. Yes, we avoided interest for 800 and 1,200, right? Good, very good. Okay, next, scheduled payment 1,200 due in 1 year ago and 1,000 due 6 months ago to be replaced by payment 800 now and second payment of 1,009 months from now and final payment 18 months from now. What is the size of the final payment if interest is such and such? Okay, let's make a timeline. 1 year I have 1,200. 6 months 1,000. Now let's say instead of that I pay 800 now. 9 months from now, $1,000. Final 18 months. So where's the focal date? People, 18 months. Very good. Focal date is here. So in this case, I have more than one payment. So I don't want long sentences, right? Where I can easily make a mistake. So I separate them. Actually, I want black color for agreement 1. I want to color code them, right? So A1 is 1,200. Now interest rate 10.8 compounded quarterly. So it's 1.027. Now what I have 12 plus 18, I have 30 months, so exponent 10 plus $1,000. By all means, guys, if you need explanation for any number, let me know. 8. Where do I have page? Yes, I do. So agreement 1 is, let's calculate, 15,634 plus 1,237.55. Add them up. 2803.89. That's agreement 1 and focal date. Let's work with agreement 2. And it is 800. 18, that's 6, right? Plus $1,000. 1,000. 27, 9 months is 3. Okay, plus X. A2. 938. 67 plus 1083.21 plus x, so 938.67 plus 1083.21, $2,021.88 plus x. Okay, let me know when you're ready for me to flip a page. Okay, so now both agreements calculated in the focal date, I can make them equal. So 2803.89 equals 2021.88 plus x. So x from here is $782.01. That's it. Any questions? Okay, so let's move forward. Let me see something. Okay, let's do this question and then we will have a break. A loan of $3,000 borrowed today is to be repaid in 3 equal installments due in 1, 3, 5 years. What is the size of the equal installment if money is over 7.2 monthly? Okay, so now 3,000, and we have installments 1 year x, 3 years x, 5 years x. Where's the focal date, guys? No, yes, that's correct. Focal date is no. And again, I have 3,000 single element from agreement 1. It makes sense to create equation right away. So 17.2 monthly, what is that? 1.008 minus 12. Okay, still 0. Plus x 1.008 minus 36 plus x 1.008 minus 16. So 3,000. Let's calculate 8 or 6. Let me double check. 6. Let me put lights on. It's dark. It is 6. Guys, why you don't correct me? I have typo. And you say, yeah, it's okay. It's not okay. Now it is okay. So 930731112 times x plus 0.8062555507 times x plus 0.69842722 times x. So 3,000. That's 2.4355413839 x. From here, x will be 123,182. Okay, guys, what is the cost of this loan? What is the cost of this loan? Nah, that's a payment. That's a payment. 3,000, that's the loan amount. Cost, that is interest, what you pay. What is interest, people? Interest, it is amount. It's a difference between what you pay and what you borrow. So 3 times 1231.82. That's how much you pay. Minus 3,000. That's how much you borrow. And the result would be 695.47. This is cost of the loan. Or interest. Understood? Okay. So on this happy note, let's make a break. Make it 5:57 back. Yeah, sure, right there. So you can write a sentence. If I pay loan, interest what I pay, calculated as amount I paid minus amount I borrow. This interest called cost of the loan. Okay, so here, 5. Yeah, let's do it 5. Let's do 5. So break, guys. Okay, guys, 5 p.m. Let's continue. So, chapter 10, further topics. Let's work with formulas first. So, future value we already know, right? It's M. Present value we already know. Here we have that we change color T together with time, opposite to time. What else? Else is I, J over M, N is Tm, and Jm, that's notification we adopted for the convenience. Then we have next few formulas. One is for N. Right, this formula pairs with this formula. And formula for I, that's PV minus 1. This formula pairs with this formula. Also, we know formula for effective interest rate, which is this. Any questions? Any questions, guys? Oh, just 2 people. That's great. Okay, are you guys back? Say I if you're here. Okay. Good. So let's practice. Let's practice. In how many days will 580 grow to 600 at 5% compound month? So 4.5. N is logarithm 600 over 580 logarithm. So let's see what is 4.5 monthly. 0.00375. Okay, so 600 over 580 logarithm. So I have 9, 0, 5, 7, 3, 5, 3, 9, and 2. Those are months, right? So because I don't actually have, I'm not certain which part of the year is it, and months are fluctuating, like 30, 31, 28, right? So it makes sense first to convert this to years. So divided by 12. I have 0.7547794998. That's years. And now because I need days, finally I can multiply by 365. That's 275.4945.169 days. So I would say approximately 276 days. 276 days. Any questions? Okay, let's continue. If an investment of 800 earned, okay, let me know when logarithm. It's logarithm ln. Guys, well, I hope that you see this formula is not first time. Just analyze what it could be. ln. Okay, so investment of 800K, earned interest of 320, and 6% compound roughly. For how many years was the money invested? Again, n is logarithm. Here we need what to calculate future value. It would be 1120 over 800 logarithm. Now 6% monthly is that. So let's calculate. Divided by 800 logarithm divided by 67.4625, and those are months, right? So I need years, and therefore I divide that music by 12. 5.62187863 years. That's for how much? I can say approximately 5.6 years. Or 6 years, actually 5 years, 7.5 months. Right? But they say how many years. So that's how. Questions? Okay. If you borrow 1,000 on May 1, 2023 at 10% compounded semi-annual, and interest on the loan amounts to 257.63, on what date is the loan due? So I would say we need what number of months, probably, or combination years and months. We'll see. So n logarithm. So interest plus principal gives me future value, right? That's what it is. Logarithm 10% semi-annually, it's probably that. So let's calculate. Okay, so 1157.63 divided by $1,000 logarithm divided on 1.5 logarithm. So 30.12 is it? Hold on, 3, not 30. For some reason, it's so 30. It is 3. 3.000088526. So those are semi-annuals. So I say we not always do that, not always possible to do that, but in this case, we can just drop that. Usually we keep it till final answer, but this 4 zeros brings that tail to nothing. So I have 3 semi-annuals. So semi-annuals is what? If I divide it by 2, I have 1.5 years. So, or 1 year, 6 months. Make sense? So from here I can dance. 1 year from May 1 to 2023 is May 1, 2024. So plus 6 months I count. June, July, August, September, October, November. And I say November 1, 2024. 4, it is due date for that loan. Questions? Okay, moving forward. Joanne borrowed 3,000 to David, understanding that she would repay the loan in 2 payments, 1,600 in 1 year and second payment of 1,700. If interest is 8% compounded quarterly, when should the second payment be made? So we have here what? Equated date. So now $3,000. And repayment is 1 year, 1,600, and sometimes in the future 1,700. Now, do we need focal date here? Yes or no? Okay, what is it? Now, beautiful. Very, very good. So again, 3,000, it's a single amount, and I can create equation right away. So 3,000 now has to be equal to 1,600 brought to now 8 quarterly is 0.2, so minus 4, right? Plus 1,700, 0.2 minus n. We don't know what time point. So let's calculate everything what we can. So 3,000 equals so 1,478, 15 plus 1,700, 1.02. It's 1.02 negative. Okay, working further. 1521.85 equals to 1700, 1.02 negative n. And at this moment, right, I remember that I have formula, and this formula exactly look at as the present value formula. Therefore, I can claim that 1,500 and change, it is present value, and 1,700, it is future value. Any questions regarding that point? No. So let me flip a page so we can continue, and we can go and find n right away. Logarithm 1,700 over, what was it? 1521.85 logarithm 1.02. Okay, let's find it. So 5.59 0.245646. So we calculated those are quarters. Now let's see what we have. We have years, right? So let's divide by 4 and we'll find years. So we divide by 4 and I have 1.397561411 years. I can say approximately 1.4 years, and that's the moment when, or if I want month, I could transfer. That's about 4.7, 4.8 months, so 4.5, so 0.5 months, 1 year, 5 months. But we actually don't know exactly how to provide the answer, so we say approximately 1.4 years. Questions? Yeah, sure, right there. Okay, ready to go? Okay, next. Joe's Furniture had financial agreement whereby two payments were required, 14,000 8 months, 15 and 14 months. Instead, these two payments, a single payment of 29,000 could be made if one is worth 10% compounded monthly. When should the single payment have to be made? Okay, let's have a picture. So now 8 months. That's 14,000. 14 months. That's 15,000. So instead of that, we have somewhere here 29,000. And again, that's your judgment when where to put that mark. On the big scale, it doesn't matter. You can put it here, here, or in the middle, the way I did. Um, the main thing is in the future, not in the past. That's it. So focal date is now, and I have one payment here, but numbers are quite big, so I think I can make agreements. I can calculate them separate. And again, it's arbitrary. It's up to you how you want it. You want to calculate it separately, do it. You want to make one equation right away, do it. So that's the interest. And 8 months monthly, so minus 8 plus 1500, I mean 1000 in period minus 14. So agreement 1 equals 13,172 plus 13,354.68. So together 26,455.40. Now agreement 2, it is 29,000, 1.0083 in period, negative net. That's it. So now I can make my equation. So 26,455.40 equals 2900, 1.0083 in period minus L. So when I call one is future value, one is present value, I always want to make sure that future value is greater than present value. Right? Otherwise I would have funny answer. Otherwise I would have payment in the past. So n is logarithm 29,000 over 26,455.40 logarithm 1.0083 in period. So let's see, what is that? So it 1106611183. So let's see what is that. And those are months. So again, I say, well, this 0, I just drop it. Oops, come on. I just drop it. So I would say approximately 11 months. Okay. Questions? So basically I dropped 2 days, about even a little less. 2 days. Okay, let me know when you're ready. Next, Yinli deposited 800 into savings account that compounded interest monthly. What nominal annual rate compounded monthly was earned on the investment if the balance was 952.75 in 5 years? So deposit 800, M is 12. Balance in the future is future value 952.75. Time is 5 years, and I need J12. So first we calculate I. So 952.75. That should be point here. Over 800. Now N is 60. 60 minus 1. So let's find I. Zero point 0.002916.592, and since I need to find actual nominal interest rate calculated monthly, so I times 12, 0.034999102. So I can say that J12 approximately 3.5%. And it's pretty good accuracy, I would say. Those 3 nines gives us good rounding. Questions? Can we continue, people? Okay. What is the effective annual rate of interest if 450 grows to 750 in 3 years at 5 months compounded monthly? Okay, so I have present value of 450, future value I have 750, time I have 3 years of 5 months, and M is 12, and I need effective rate F. So let's do it. So first I find I, 750 over 450. Yeah, no. First I find N, because I have interesting T. T is 3 years 5 months. So what is it? 3 plus 5 over 12, and 5 over 12, so plus 3, 3.416 in period. And now right away I go and find n by doing times 12. It is 41. So n is 41. Now I'm ready to find I. 750 over 450, 1 over 41 minus 1. So I is 0.012537. Let me double check. Yes. Question is not asking me what is J12. Question is asking me what is F, right? So, and I remember that F actually is 1 plus I exponent m minus 1. So I already have I. So let's use it. Exponent 12 minus 1. Let's see. That is 0.161265012. So F approximately 16.1265%. Just to demonstrate J12, if I do this, I would find 1504%. So J12 will be 1504, F will be 16.13. Okay, questions, guys? The answer here is 16.1265%. Let me know when you're ready to continue. Okay. An amount of 2,300 earns 500 interest in 3 years, 2 months was effective annual rate of interest compounded monthly. So we have same thing. I. Let's find n first. So t 3 plus 2 over 12. What is it? 2 over 12 plus 3. 3.16 in period. Now I times 12. 38. That is n. Now I is so 323 2800. That's the future value over 2300. 1 over 38 minus 1. Let's see. 0.0051900008. So that is monthly rate. And I need effective, so again I continue with formula for effective rate. I just calculated 12 minus 1, so let's see. 0.064, okay, like that. So F approximately I would say 6.4089%. Again, if you need less accuracy, you can go 6.4, 6.41, whatever. Questions, guys? Okay, can we continue? We have two more questions. Okay, so next, what is the nominal rate of interest compounded quarterly if the effective rate of interest and investment 5.3? So this time we know F, 5.3%, and we're looking for J4. They have to be equivalent, right? So meaning they will work with the exact same result. For two rates to be equivalent, we must follow these conditions. So amount of investment same, time of investment same. Usually for that purposes we take T 1 year and present value is $1. So 1.053, that is future value for $1 with J1 5.3%. Has to be equal for this. We'll start with exponents. Continue, I is 1.053, exponent 1/4 minus 1. So I is, let's calculate, 0.01299451, and this rate is quarterly, so I finish with times 4, 0.05197805, so J4 approximately 5 point, again depends on accuracy, we can put this. Questions? So I remember that relation between number and number of compounding intervals per year and actual nominal rate is reverse. It means the more I compound, the less nominal rate I should charge. And if you look at 5.3 compounded once a year, it will change to 5.2, let's say, compounded quarterly. So it dropped. Right, guys? So let's continue. We have here, what is equivalent interest rate to 10% compounded quarterly if compounded semi-annually, compounded monthly? So what do we know? Let's answer question 1. We know that J4, 10%. So again here, T is 1 year, present value is $1. So future value for that guy, let me, that's 1.025 exponent 4 equals to 1 plus I exponent 2. Now working with exponents, 4/2 equals to 1 plus I, that's 1. So I would be 1.025 squared minus 1. I is, okay, so 0.050625, and I remember that I have to finish my calculation by times 2 because I'm looking for J2, right? So 0.25. So J2, it is 10.125%. And again, I observed that I decreased number of compounding periods. From 4 I have 2, so I had to increase a nominal rate. From 10 I charged 10.125. Okay, so let me know when you're ready to continue for next page and question 2. Okay, so what do we have? For question 2, we have again J4, 10%. But now we compound monthly, right? Yes. Okay. What do we have? 1.025 exponent 4 has to be equal to 1 plus I exponent 12. Okay, first step is to work with exponents. 4 over 12, basically divide one on another. 1 plus I, so I would be 1.025, 1 over 3 minus 1. So let's calculate I. That is 0.008264838. And I remember I have to find J12, so I need 2 times 12. So 0.099178051. So J12 approximately 9.9178%. Again, I observe that a reverse relation, right? I changed number of compounding periods. I started charged 12 times instead of 4, and for that I had to decrease nominal interest rate. Of course, if those rates, they have to be equivalent, because if I just use the same nominal rate and just increase number of compounding intervals, I simply start to charge more. Okay, people, any questions? Okay, on this happy note, we finish class. Here's your homework. So this Friday, no class. It's a Good Friday. And then following Wednesday, which is a week from now, it will be reviewed before final exam. I hope you will have enough time to go through review exercises and prepare questions you want to ask me. Okay, so see you Wednesday. And happy Easter if you celebrate it. And thank you for coming. Goodbye.